Hello and welcome back everybody to geometry. Today we will be looking at section 17.3, which is on the ratio amongst relationship between the trig ratio. So in just as a recap, what we learned about in the last couple of sections were the three trig ratios: sine, cosine, and also tangent. And for each one, they represent a certain ratio. For sine, we define it as the opposite side of the angle divided by the hypotenuse, and assuming all of this is in a right triangle. Whereas cosine is supposed to be the adjacent over the hypotenuse, and then the tangent of the angle is supposed to be the opposite over the adjacent. So you can see the illustration that's on the right-hand side that we have a right triangle we call ABC, with side A, B, and C also. So underneath over here, you can see my ratio for sine, and whenever you take the trig ratio, you have to take the trig of an angle. So that means that you can't just say sine, you can't just say cosine, nor can you just say tangent. You have to say the sine of what angle, or the tangent of what angle, or the cosine of what angle. So in our first part, by our definition, the sine of angle A. Now, angle A is located right here. That is supposed to be opposite over hypotenuse. So opposite of angle A is going to be this guy right here, BC, which is denoted as side of length A. And then the hypotenuse will then be C over here, and that is going to be denoted as C that's over here. So C, the hypotenuse, is always consistent, but what changes is the opposite and also adjacent depending on what angle that you actually have. And then in the second case right here, cosine of angle A is going to be adjacent. So I kind of messed up right here. So let me go ahead and replace that definition. So that is going to be adjacent over hypotenuse. And the side that is adjacent to angle A is then B over here. So that's why you see B that's up here. And then the hypotenuse, once again, is going to be side C. Whereas tangent of angle A, the opposite is going to be A, the side, and then adjacent is going to be B, the side. So A over B is going to be the ratio there. Now, that is going to be the trig ratio for the angle sine. We can also, in the same triangle, find out the following. What is the sine of the other angle, angle B? And in this case, sine of angle B, B is located right here. Let me just go ahead and erase, some of this mess over here first, just to make it a little bit easier to see. So let's see, going back to what we're saying, if we're referring to angle B right now, then that means that AB, the side, this right here, that is going to be the opposite. Whereas A over here, the side, that's going to be my adjacent, and the hypotenuse would then stay the same. So sine of angle B, which is again opposite over hypotenuse, will then be B over C. Cosine of angle B is going to be then A over C because it's adjacent over hypotenuse. And finally, with the tangent of angle B is going to be equal to the adjacent over the opposite. Opposite over adjacent. So that means it's going to be B over A. Now, here's what I want you to notice then. In this right triangle, you'll notice that these ratios right here, some of them are actually identical to each other. So for example, over here, let me just kind of erase these two over here and erase these over here. For example, over here, you see that BC, the ratio BC, that is in reference to cosine of angle A and also sine of angle B. So by the transitive property, I can say that those two are going to be equivalent to each other. So that is to say that, I guess this is kind of like a theorem now, that cosine of angle A is equal to sine of angle B, so long as A and B are complementary of each other. So that means that the sum of them have to be equal to 90 degrees then. Then if you look at another scenario, we can then look at sine of A over here, right? Which has a ratio of A divided by C. And then that's going to be the same as cosine of angle B, which also has a ratio of A over C. So that means that the sine of an angle is equal to the cosine of the other angle, again, so long as provided that A and B are complementary to each other. So that right there is kind of like a theorem that we can actually use. We can actually take these to make it a little bit easier. If we want, we can go ahead and write the following. Cosine of A is equal to sine of, rather than writing angle B, we could also write 90 minus A because remember, they are supplement to each other. And then similarly, for the other one, we can say that sine of an angle is equal to the cosine of not the complementary angle, but rather 90 minus the angle that you actually have. So any one of these four variations should be acceptable then, okay? So let me go ahead and highlight them. So this guy right here, and this guy right here, and this guy right here, and this guy right here, that makes one whole theorem right there. And I think it's called theorem 17.3. There's really like no name for it, unfortunately, okay? Then, are there any other relationship between these trig ratios? The answer is yes. In addition, notice that the triangle that we're using right here is a right triangle. So what that means is that we can actually do the Pythagorean theorem for this. So if I were to look at the Pythagorean theorem, a squared plus b squared is equal to c squared. Okay, a squared plus b squared is equal to c squared. Now, what I can do is I can take this Pythagorean theorem and then divide everything by c squared. So that would then give me a over c squared of each one plus b squared over c squared is equal to 1. And note, if you go to our ratios over here, a over c and b over c, well, they represent something. In the first two cases right here, right, we can say that a over c can be replaced with sine of a. So that is to say that this is going to be sine of a quantity squared. And then this part over here, we have b over c. We can say that that is going to be cosine of a and then quantity squared. And then that all is equal to 1. So just to kind of clean it up a little bit, the expression that people usually write for this is sine, and then they put the square in between the two angle and also the trig ratio, just to not get it confused, plus cosine squared of a is equal to 1. So that right there is actually the premise, or the very important, actually let me go ahead and move this over because I don't want to mess that one up. That right there, the identity, this is what is known as a Pythagorean identity, and it's basically the basis of the trigonometry, which you will learn more about in 2 years. So this right here, let me go ahead and kind of highlight, because that's going to be another theorem that we're going to be using. Okay, so there it is. And lastly, there is one more theorem, and that's the following right here. Focus on tangent, okay? So focus on tangent of an angle. If I say the tangent of an angle, well, by definition, that is supposed to be the opposite over the adjacent, right? Because that is the definition of tangent. Now, what I can do is I can take that and do the following. Let me take that fraction on the right and split it into two parts. We're going to say opposite divided by and then adjacent is going to be over here. I'm going to kind of like complete the square, or, you know, fill in some blanks right here. Let me go ahead and divide by the hypotenuse and multiply by the hypotenuse, just to kind of balance the equation right here. Well, if I do so, then that means that we have something very unique over here. This right here, opposite over hypotenuse, that's going to be the sine, right? Because that's how sine is defined. So that right there is going to be the sine of A. Now, this part over here is a little bit harder to see, but if I were to write it as divide by adjacent over hypotenuse, basically kind of like, you know, going backwards by saying I'm going to divide by the reciprocal, then this might look a little bit more familiar. That right there is the cosine of an angle. So then that means that tangent, we can actually write it as sine of A divided by the cosine of A. And that right there is going to be our third identity. Okay, so here it is, sine over cosine of A. All right, so I'm going to go ahead and highlight all of these guys right here. Okay, and let's see what we can actually do with all of these identities that we just proved over here. Now, to make our lives a little bit easier, what I did was I wrote them here on the side so you can see the identities over there that we can use. So those are kind of like the theorems that, well, they are the theorems actually that we're going to be using for this section. Okay, so they are what is known as the identities. Okay. All right, so with these identities, what I want to do is I want to use them to prove new identities. So in a way, it's kind of like a puzzle, right? You're going to give, you're basically given three information, and I want to use that to prove other information, which I'm hoping are going to be true. So here in this first problem, what I want to do is I want to prove the following identity then. Notice an identity is basically just an equation with a whole bunch of trig equations in there. Okay. So in this case, we have the tangent of x multiplied by the sine of x plus the cosine of x is supposed to be equal to 1 over cosine of x. Now, in terms of how this actually works out, you have to treat it as a proof. So what that means is you can only work on one side of the equation to show that it's equal to the other side of the equation, because it's kind of like saying that here, the left-hand side, that's going to be my given, and this right here is what I need to prove. So we can't actually kind of like work on both sides of the equation, okay? My goal is to do some sort of algebra and or some sort of identity to prove that the left-hand side is equal to the right-hand side. Okay, so let's go ahead and give it a shot then, okay? Now, since the left-hand side looks a little bit more complex and there are more things to work with, we can go ahead and say, hey, let's go ahead and work on the left-hand side. These identity problems, you can choose which side to work on. And I always try to work on the most complex side just because, again, it's like a puzzle where you're trying to figure out where you have like more things to play with, okay? All right, so on the left-hand side, I notice that I have tangent, sine, and cosine. And what I want to do is I want to change it to 1 over cosine. If I'm looking at the identities that I know, which are over here again on the right-hand side, the question is, which one of these can I actually use in here? Well, I definitely see something that could be useful, and that's the second one over here, where tangent of theta is equal to sine of theta over cosine of theta. Okay, so here, let me just go ahead and do a replacement. So tangent of theta, tangent of x, I'm going to now write that as sine of x over the cosine of x. And then we still have all the other stuff, sine of x, and then plus cosine of x. Okay, let's see. Now the first term, we can kind of clean that up a little bit. That is going to be equal to sine squared of x over cosine of x. And as soon as you notice that, hey, the left-hand side, there's a fraction, maybe I should take the right-hand side and create it so that, rewrite it so that way it's a fraction as well. So what I mean is that over here, let's take the second term and multiply cosine of x divided by cosine of x to both top and bottom. That way we can get a common denominator. So if I do so, then now we have cosine squared of x divided by cosine of x. And the reason why I want a common denominator is so that way I can combine the two terms. Okay, keep going. Now that I have a combined term on the bottom, that's cosine of x. On the top, I have sine squared x plus cosine squared x. All you're doing is you're just going back between identity and also algebra. If you can't do identity, you do algebra. If you can't do algebra, you do identity and so forth, okay? That is pretty much the exhaustion of all my algebra that I can see. So now we're going to go back to the identity and see if there's something that we can replace. And the answer is yes. Looking at my top, the numerator, you'll see sine squared plus cosine squared of any angle is always going to be equal to 1. So then that means I can replace 1 in the numerator, and then the denominator will stay the same. And note now in the very end, that is equivalent to what I want to prove on the right-hand side. So there you go. That's how an identity works then. So once again, it's basically just an algebra problem where you're just doing algebra and then replacing the identities to make sure that one side looks like the other. Okay. All right, let's try a few more identities just to kind of get the hang of it. Okay, so let's now go to the middle one right here. So here we have sine of x minus sine of x times cosine squared of x is equal to 1. Again, in this case, I'm going to go ahead and choose to work on the left-hand side because there are more things to play with. So let's go ahead and attack it then. So the first thing you should always ask yourself is, okay, in terms of algebra and identity, okay, what can I possibly do? Well, go down the list. Let's look at algebra, right? If there's something we can do algebra, then we'll go ahead and do it. If there's something with identity, we'll go ahead and do it. There's no, one direct path that you can take right here. So as soon as you see something, just go ahead and approach it. In this case, I noticed that algebraically, I can take out the sine of x that both terms have in common. So meaning factor. I'm going to factor out the sine of x they both have in common. And if I do so, the first term, all I have left is 1. The second term, all I have left is cosine squared of x, okay? And then that is going to be equal to supposedly 1 in this case. And I think I see a mistake right here because on the right-hand side, I do believe that this actually should say sine of cube x. So let me go ahead and make that small little minor mistake. I do apologize for that one, okay? All right, so now we ask again the question, okay, can you do more algebra or can you do more identities, right? You always go between the two. Algebraically, I can't do too much. If I multiply it out, I just go back to the same thing. So then that means that that's going to be no longer an option for the time being. Now we're seeing if there's an identity. Now, looking at our identities over here, you'll notice that what I have right there isn't exactly the same as what my identities have on the right-hand side. But there is one that's like kind of close to it if you move some terms around. And that's once again, this guy over here at the very top, right? Notice that what I have right here, 1 minus cosine squared x, well, if I take the cosine squared and move it over to the right-hand side, then that's exactly what I have. So on the side note, if you guys can see it, and if you need to write this down, go ahead and do so, but it's really not necessary. Sine squared theta plus cosine squared theta is equal to 1. So if I subtract cosine squared theta from both sides of the equation, then what I have is sine squared theta is equal to 1 minus cosine squared theta. And that right there is going to be my replacement over there, or substitution with the identity. So that now leaves me with sine of x multiplied by sine squared of x. And if you have sine of x times sine squared of x, that's going to come out to be the sine cube of x then. Okay, well, there you go. That's going to be our problem then. All right, let's take care of this last one over here. Okay, this last one over here is going to be 2 tangent of x is equal to cosine of x divided by 1 plus sine of x, and then minus cosine of x divided by 1 minus cosine of x. So let me get rid of that equal sign that's not supposed to be there. This time around, I'm going to choose to work on the right-hand side because I noticed that the right-hand side over here, this is definitely a lot more complex. So that's probably going to be my starting term. I want to take that and clean it up and make it look like the left. Okay. So again, thinking about algebra and then also identity over here. Now, algebra, what I can do is I notice I have two fractions that are not the same denominator. So usually what I would like to do is probably combine them together if possible. Right now on the right-hand side, it's kind of like something like 1/2 minus 1/3, and I want to make it so that it's nice and clean. Because the left-hand side, look, you only have one term, so it only makes sense that I want to get a common denominator in this case. Okay, so let's go ahead and do that then. So on the left, I'm going to go for a common denominator. So I have cosine of x divided by 1 plus sine of x. I'm going to go ahead and multiply to both top and bottom 1 minus sine of x, like so. Okay, so 1 minus sine of x. Then for the other term, where we have minus cosine of x divided by 1 minus sine of x, I'm going to multiply by the other term's denominator, which is 1 plus sine of x, and I'm going to choose to multiply that to both top and bottom. Okay, so now we have to kind of clean up the algebra because that's usually what happens. Let's see, we're going to get a really, really big fraction over here. The bottom fraction is going to be 1 plus sine of x multiplied by 1 minus sine of x. The numerator, well, that's going to be all these guys over here. So we have cosine of x multiplied by 1 minus sine of x. Okay, and then we have minus cosine of x. And then we also have multiplied by 1 plus sine of x. Okay, keep cleaning it up as much as you can. Okay, let's see here. Maybe I guess I can multiply out the bottom part, right? The bottom part, we can go ahead and expand it out by using FOIL. So 1 times 1, that's going to be 1. And then 1 times negative sine, so that's going to be negative sine of x. And then sine times 1, so that's going to be plus sine of x. And then finally, sine of x times negative sine of x, so that's minus sine squared of x. Okay, so that's nice because look, the sine and the negative sign, they cancel each other out. So we get something kind of nice and clean in the bottom. The numerator, well, I can go ahead and multiply everything out also. So let's see what what I get from there. So first term, it's going to be multiplied here. So that's cosine of x. And then we have minus cosine times negative signs. So cosine of x times sine of x, okay? And then we have minus, for the other part, we'll do the same thing here. These two multiplied together, that's going to be cosine of x negative. And then finally, for the last one over here, that is going to be, looks like it's going to be minus, let's see, looks like it's going to be cosine of x, and then times a sine of x over here, okay? And I think there is a small little mistake over here because if I notice, there are certain terms that are not going to cancel out. So once again, I'm going to do like a quick impromptu fix to the problem at the very beginning, which I think I see is the problem. I think this guy actually is supposed to be a plus. So let me see if I can change that over here. Yeah, let me go ahead and change this to a plus, change this to a plus, and change this to a plus over here. And that'll probably take care of our mistakes. Okay, there it is. All right, so hopefully we don't have to do that in the textbook, okay? Let's see, in terms of what cancels out, hey, the top, the negative cosine sine and the positive cosine sine will cancel each other out. So after we trim out a few more terms, the numerator is just cosine of x plus cosine of x. So that's 2 cosine of x because it's an apple plus an apple. Whereas the denominator is going to be 1 minus sine squared of x. And if you remember what we did in the previous problem, we can go ahead and take the bottom part and change it so that it becomes something nice and clean. So then that is going to be 2 times the cosine of x divided by cosine squared of x. And if we clean that up, that is going to give us now 2 and then divide by cosine of x. So I think maybe I shouldn't have made that change because that's giving me a different answer now. But hopefully, you know, these kind of embarrassing thing never ever happens to you guys. So this guy right here is supposed to be 2 multiplied by 1 over cosine of x right there. Okay, sorry about that. All right, so there you go. That's the idea behind the identities. And hopefully you have a good understanding of this. All right, I'll see you guys next time then. Goodbye.